Well, folks, you might notice that we've got a guest here. We've got a future chemistry teacher. This happens to be Miss Bergmann. She is related to me.
Not at all, not at all.
My wonderful daughter. We're studying to be a chemistry teacher. And today, in this video, we're going to talk about the concept of dilutions.
Huh? What does that mean?
Dilutions is when you make things less concentrated. So if I've got a solution that's like super concentrated, say this picture right here, if I want to make it less concentrated, you can see that in a less concentrated picture here, that it becomes less dark, if you will.
I can see that, totally.
Yeah. So in a dilution equation, when you're doing dilutions, it actually becomes mathematical, and we use kind of an important equation. What's that important equation to make it? They're super crazy simple, guys.
So crazy simple, don't complicate it. People make it way too complicated. So we have M1.
Molarity 1.
Volume 1.
Volume 1.
Equals molarity 2. Volume 2.
Now usually, folks, on this one, you want the molarity 1 to be the more concentrated solution, molarity 2 the less concentration solution. And yeah, well, I think the best way to do this is like, let's just do a problem. Let's do a problem.
Okay, yeah.
All right. So in this particular problem, we have 22.5 milliliters, as you can see up here, of a 2 molar stock solution. Now, when I say a stock solution, that's the more concentrated solution. So this is 2 molar, and it's like darker, right?
Okay.
And we have how much of it?
22.5 milliliters, I believe.
And we're going to dilute it to 250 milliliters.
Okay.
So we're going to take 22.5 of this, and we're going to put it in a much bigger flask, right? And we're going to put in here 22.5 milliliters. And then we're going to fill it to the 250 mil mark.
Yeah.
So the question is, how concentrated? What's the molarity of the less dilute solution? What are we going to do?
So, well, molar we know is our first molarity is 2.
So that's M1.
Yeah, and then looks like that's our volume 1.
V1.
And then this is a volume, so V2. Right?
So how would you substitute that into your equation?
So if I have M1, V1, I'm going to take 2.0 molar.
Yeah.
And
I'm going to
then,
be getting a calculator out, Ms. Bergmann, while we're setting that up.
And the fun thing here is you can use, if you have milliliters on both sides, you can use milliliters. You don't have to worry about changing it to liters.
Oh, really? Oh, that's pretty cool.
Yeah, it's a pretty cool trick.
Milliliters, got it. And that equals what?
Sorry, folks.
Yeah, but the other side, that's fine. What's M2?
So this would be 250 milliliters, and we're looking for M2.
Well, I think all you got to do, this times this is equals X times 250, so I divide both sides by 250, right?
Yeah.
So why don't you show that?
Because if I divide by 250
Yeah.
and divide by 250...
The 250s cancel, don't they?
No naked numbers.
Yeah, I don't like naked numbers. 250s.
The milliliters cancel out.
And also the 250s cancel out.
250s cancel out.
So I'm going to take 2, got the trusty dusty calculator here, right? I'm going to take 2 times 22.5.
Divided by 250.
Not times 22. All right, Mr. Bergmann messed up here. It's 2 times 22.5, not 225, which is what I did.
Yeah, don't do that.
Divided by 250. And that gets me 0.18.
Okay, M2 is equal to 0.18, what?
Capital molarity.
Molar.
Now that makes sense if you think about it, folks. It was 2 molar, and we diluted it, so the molarity went down to 0.18. So that makes sense, right?
Okay. Yeah, that makes sense.
So here's our second example, Ms. Bergmann. So how would you make 100 milliliters of a 0.25 molar solution of NH4OH, ammonium hydroxide, given this 2 molar stock solution? So I'm trying to paint a picture. We've got a stock solution, right?
Yeah.
A little beaker, and it's 2.0
molar.
Capital M. So we've got quite a lot of it, probably.
Yeah.
But I need to make up 100 milliliters of a 0.25 molar stock solution, or of a solution.
Yes.
Now this one, you might be tempted to use M1V1 equals M2V2, and that's not going to work, because we've got to get to what? Or maybe I do. Yeah, I do.
Yeah, you do.
I need to do it, so I need to use my equation, right? So M1 V1 equals M2 V2. So what do I need
So
to
we
do?
should probably label what we've got, right?
So the first one should be,
Our molarity 1 is equal
that's this right
to
here.
2 molar, right?
That's our stock solution.
We don't have the volume of...
We don't have volume 1, do we?
No. So that's our big question mark. But
So I'm going to say 2.0 molar times V1 equals,
RM2, which is 0.25.
here's it right here, so 0.250 molar
Yeah,
times
100 milliliters.
100 milliliters.
So I think you just got to divide by 2.
That's divided by 2. That gives me a number, but that doesn't tell us how to solve the problem. The 2's cancel. And so I can just take 100 times...
2 molar.
Yeah, 2 molar. Yeah. So I get my trusty dusty calculator out. And I'm going to take 0.25 times 100 divided by 2, right?
Mm-hmm.
And I end up with 1.25. What's that going to be?
So
The molars cancel.
it's milliliters.
So, guys, this is an interesting question. That's not the answer, but that's what's going to be used to get the answer. So what you're going to need to do is you're going to have a container, one of these volumetric flasks with the one line, and we're going to get one that's the size of 100. So this is a 100 milliliter volumetric flask. And I need to do what?
You need to take 1.25 milliliters of that stock solution, put it in here, and then add more water.
So you just put a very small amount in here, just 1.25 milliliters, and then add like 99 or something like that, whatever, to fill it up. So that's actually a trick on how to do that. The technique on how to do it uses not only these volumetric flasks, but also a new cool tool called a pipette. So let's cut to a video where I show you how to actually make something like this using the glassware that we have in class. So when we're doing dilutions, how do we actually physically do it in class? Well, the answer is that we have a concentrated solution. Let's say I have this orange solution, chromate, and I want to dilute it, and I want to add some water to this. So I'm going to take this chemical right here, pour a little bit of this in here, and then it'll be diluted, and that's more water. But we don't want to just sort of add a little. We want to know exactly how much we do that. To do that, we use something called a pipette. Now, there's two kinds of pipettes. This one with the big fat thing in the middle, and if you look carefully, you'll notice there's a number right there. It says 15. So if I fill this up to the line, and you'll see a line, there's a line right here. I don't know if you see the line. That's exactly 15 milliliters. The second kind of pipette we call a graduated pipette, and this one has numbers on it, and I can get exactly how much I want. Now the graduated ones are kind of cool because you're going to get exactly 15 milliliters of the liquid. Now the art, how do you do this? Right? So I've got a bulb, and I stick it on the end. All right, stick it on the end. I squeeze it. I hear air popping out. I then put it into the solution, and you can see that the liquid is being drawn up into the pipette. Do you see that? Now this is where the trick comes, all right? I'm actually holding onto the bulb. If you look careful, the bulb's coming up. If you can quite see this, the liquid's coming up in the liquid, and it comes up in the tube, and the line, it's now gone past the line. Now this is where the trick is. I'm going to then hold it down here. Let me tilt the camera up so you can see exactly what I'm about to do. This is the technique that you don't want it to go up into the bulb. What I'm going to do is I'm going to take my hand, I'm going to quickly, notice I'm still squeezing on the pipette. I'm going to just pop this off and stick my hand over the top. Now my thumb is over the top. And now this is a pretty precise thing. I don't know if you can see this. I'm going to allow the liquid to drop. I'm just going to relieve pressure. Bring the camera up here. I'm going to just take my thumb and just relieve a little pressure. And when I relieve a little pressure, watch what happens. The liquid goes down. And I'm going to do this right till I get to the line. And I want to do the line where the bottom of the meniscus is right on the line, which is exactly what I have. And so now what I have is I have exactly 15 milliliters. I can then just put it into this other flask. This is called a volumetric flask. And I can release, and you can see the liquid is going down into the flask, slowly and slowly and slowly. And it's filling the flask a little bit at a time. And I'm delivering exactly 15 milliliters of the chromate solution. Drip, 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 drip. 15 milliliters. So now I have 15 milliliters exactly right here. Now this is a 100 milliliter volumetric flask, another super duper accurate device. And then what I can do is I can now just fill this up. And this also is a super accurate measuring device. Actually, what I often do, I'll cheat, is that I'll pour the water in directly, but I'll slow way down when I get to the end. All right, so now, I don't know if you can see this, but now I'm at the tip of the neck, but the actual line for here is right there. So now I'm going to take the squirt bottle and I'm going to squirt it right to the line. I'm going to go super slow, super slow, super slow. And I want to stop at the line. Go over, you got to start over. Boom. Now, if you take a look, we have the dark solution, we have the light solution, and I can figure out the exact molarity of this solution because I know that I had 15 milliliters of the 1 molar chromium, which happens to be 1 molar, and diluted to 100, and I can calculate the exact molarity of this particular compound. So that's how you do a dilution. Now in class, you're going to have to learn, it's kind of practice. Again, reminder, you squeeze, and then when you draw it up to the part that you want, actually you want to go past it, flick your hand off, put your thumb over the top, and you don't take your hand off, you just relieve pressure, and then the liquid starts to drip down. It's a skill, you'll practice it in class, and it will work.
Well, Ms. Bergmann, that's how we do dilutions.
That's so cool. I had no idea.
That's pretty awesome. Use the pipette. The trick is that the bulb and getting your thumb over it and pressure. You're in some practice in class. It's tricky, but you guys are good.
Oh, it's so fun. So fun. Especially college.
Oh, yeah. See you in class.